Hi everyone, welcome to another maths video by Maths with Sarah. Today we're going to be tackling this question. I think it looks probably deceptively simple, but in actual fact there's quite a few steps. And if I told you that this was question 19 on one of the calculator papers, so quite near the back of the paper, you can understand that it probably is a little bit more challenging than it possibly looks at first glance. So as with all these questions, I encourage you to pause the video now, have a little think about how you would tackle this question, even if you can't do the whole thing, but you've just got an idea of what method you might use. So yeah, pause the video, have a think about how you would do it, and come back when you've had a chance to have a look. Okay, so this question, we've got a pentagon made from a square and an isosceles triangle. Now, hopefully you remember that an isosceles triangle has two sides which are the same length, which are denoted by this line across them, and they also have two angles which are the same. So in this case, it would be these two bottom ones. And then we've got the square, and it's asking us to work out the perimeter of the pentagon. Now, the best way to do this is to break it down into two separate sections. So if we put an imaginary line across there, you can see quite easily that we've split it into the square and the isosceles triangle. And we know, because we've been told that it's a square, that all of the angles are going to be right angles. All of the angles of the square are going to be the corners of the square are going to be right angles. And we know that this portion of that angle is going to be 125 minus 90 for the right angle, which is going to give us 35 degrees. So finding the perimeter of the section of the square, so these three sides, is quite easy. So we know that the bottom half is going to be 3 times 12, which is 36 centimetres. But finding the perimeter, or finding the value of these two, or the length of these two sides, is going to be a little bit more challenging. Now, as I've said, we know that these two angles are the same, so we know that both of these are 35 degrees, but we don't know what this top angle is. So the best way of doing it, we need to find out what one of these side lengths are. So we know that this bottom side is 12 centimetres. We don't really have any other more information than that. So the way that I would suggest going about this is to, we'll redraw out part of the triangle. So we'll just redraw out half as though we've chopped the triangle in half down the middle. And this is going to allow us to calculate the length of this side. So if we've chopped it in half down the middle, we know that this side is going to be 12 divided by 2. So that's going to be 6 centimetres. And we know that we're going to have there we go, 6 centimetres. And that this angle is a right angle, and we know, as we've already previously found out, that this angle is 35 degrees. And this is the angle that we would like to find out. So for now, we will call that X. So this is the side that we'd like to find the length of, so we'll call that X. Now, hopefully you're realising we've got a triangle, we've got an angle, we've got a right angle, we've got a length. Probably going to be needing to use some trigonometry. And this is where I said what actually looks like quite a straightforward question of just find the perimeter of this shape actually starts to get a little bit more complicated when you bring trigonometry into it. So I'm just going to switch to a different colour so that we can make it really clear what's going on here. So the way that you're probably taught to remember how to use trigonometry is by doing Sokochoa. So this is sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and tan equals opposite over adjacent, which is what that stands for. And in this case, if we label up the sides, we know that the hypotenuse is always the side that's opposite the right angle. And then we've got this angle here. So we know that this side is the one that's opposite it, and this is the side that is adjacent to the angle. Now, in this case, we have got a value for the adjacent side, and we want to calculate the hypotenuse. We know nothing about the opposite, so we know that we're not going to be using either of the ones with the opposite in it. But we are going to use the one which has got both the adjacent and the hypotenuse. So that means we're going to use cos. So we know that cos of 35, so we always do sine, cos, or tan, in this case, cos of an angle. So sine of 35 equals adjacent over hypotenuse. And in this case, the adjacent is 6. We've got 6 over the hypotenuse. And that's what we're trying to work out, is what the hypotenuse equals. So if we then rearrange this equation, so if we think about timesing both sides by h, we then end up with h cos 35. And then we can divide both sides by cos, which will give us essentially switch the cos and the h switch places. So I end up with 6 divided by cos 35. It doesn't actually matter, so you can do this calculation, work out what this is first, and then do the rearranging, or you can rearrange it and then do the calculation. Either way, you should get the same answer of 7.32 centimeters. So that is the length of this, the hypotenuse of this triangle. And as you remember, we've taken it from this larger shape. So this is going to be 7.32 centimeters. And obviously this one, because it's exactly the same triangle, just flipped around, it's also going to be exactly the same length. So it's worked. And we also know, because it's, we've been told that they're the same length, because it's an isosceles triangle. So we've now got the final two sides. We know that the perimeter of this bottom bit of the square is 36 centimeters, and then we've got the length of these two sides are going to add up to about 14.6. So if we add all of those together, then if we add 2 times 7.32, we're going to get a total of 50.6. So hopefully you're able to follow that through. I think that the most complicated bit is actually realizing how that you need to break this triangle in half in order to use trigonometry. You could possibly do it using the advanced trigonometry, so with non-standard, with a non-triangle with a non-right angle. I think that would actually be more complicated than actually just cutting the triangle in half. And I think that's the most difficult bit, is realizing that you need to chop the triangle in half to give yourself a right angle and then use trigonometry. I think a lot of people would probably assume you could do it with Pythagoras or by finding out the angles or something, but it's a little bit more difficult than that, because you need to use trigonometry. And that is probably why it's worth 4 marks. So quite a lot for what, as I said at the beginning, looks like a deceptively simple question. So please subscribe to my channel, please like the video, and please comment if you've got, or send me a message if you've got any questions or topics that you would like me to do videos on. And thank you very much for listening.